This lecture handles the transport and network layers. These are the two main layers that concern the network specialist, the network engineer. The transport layer, layer number 4, it organizes data into segments. The word segment is the unit of data at the transport layer, at layer number 4, where it is a packet at layer number 3 and a frame at layer number 2 and bits and bytes at the physical layer, layer number 1. The transport layer is responsible for the end-to-end delivery in either reliable form or just best effort delivery. When we try to explain the word reliable, we refer to loss recovery, which means that data transmitted arrives at the receiver side with no losses. We also refer to the flow control, the adjustment of the flow between the sender and the receiver according to the network conditions and according to the requirements of data. We refer also to data ordering. Sometimes data arrive at the receiver side out of order. Arrive data number 2 before data number 1. Data number 1 is late due to taking a congested path over the network. That's why data number 2 arrived earlier. I mean the piece of data. This piece of data number 2 needs to be reordered in a reassembly process to be put in the right place after data number 1. One of the responsibilities of the transport layer is the data deduplication. Sometimes data is sent twice and received twice, the same piece of data. So we need a form or an identifier that says that this data is a duplicate. This data is another copy of a certain data that has been received. So we need a deduplication process to eliminate the extra copy. Once more, you either send and receive in a reliable communication or in best effort delivery. It's the two modes where the transport layer works. The functionalities of the transport layer are, number 1, the segmentation. The segmentation means dividing data into small fragments called segments that can be transmitted over the network. Different networks have different maximum transmission unit, different MTU. The MTU defines the maximum size of one data piece carried through the network. This is the definition of the MTU. Data is being divided and transmitted to the recipient via the transport layer. The MTU size is agreed upon between the sender and the receiver while establishing the connection and during the routine discovery. The MTU size is one of the parameters of the network that must be agreed upon between the sender, the receiver, and the communication devices. The second functionality of the transport layer is the reassembly. Reassembly means assembling the pieces of data arriving at the receiver side to the same form or the same initial form that has been sent from the sender. This reassembly is done at the receiving end. The transport layer protocols reconstruct data into its initial form. Data can be received in different order, different than the form that has been sending it. So it is the responsibility of the transport layer to rearrange those pieces of data into the correct order, the original order, the order by which it has been sent. The third functionality of the transport layer is sequencing, using the sequencing identifier or sequencing number. To avoid the loss and avoid the duplication, each piece of data is noted by a sequence number or sequence identifier. This sequencing fixes the issue of following data different paths, so you know from the sequencing identifier the correct sequence of data. This sequencing helps in organizing data in groups of subdivided data segments and in identifying the order of groups of data sending and interpretation. The communication in the transport layer is either connection-oriented. This type of communication that is called connection-oriented is reliable and more secure. It is based upon establishing two-way connection between the nodes, I mean the sending and the receiving nodes, before data transmission. For example, when a browser is trying to open a web page, the transport layer would send synchronization packet to the web server from the browser. The browser then expects synchronization acknowledgement response. When it receives this response from the server, it sends its own response to the server back. After this process is done, the data can be transmitted. We can here see that no data has been transmitted before the connection establishment is complete. The transport layer can establish a connection in another mode that is called connectionless oriented. This is a non-reliable connection. This connection depends on the best effort delivery between the sender and the receiver. No connection establishment prior to data transmission. It is less in security because it does not guarantee the loss recovery or the reordering of the data if received out of order. It allows sometimes for data flooding, for sending big chunks of data over the network, causing it to flood, to be saturated with unwanted traffic. But this type of connectionless oriented communication is essential in some types of communication where data is real time, data is delay sensitive, such as the audio data in the audio calls or the video data in the video streaming sessions. Now let's move to the third layer, layer number 3, the network layer. Remember that we count layers from down to up. This layer organizes data into packets. Now remember that data in the fourth layer is called segment, and here it is called packets. Responsible, this layer, of end-to-end addressing and routing. And let's know by heart these two words, addressing and routing. These are the main functions of the network layer. The network layer identifies unique logical address for each machine over the network. The address is unique. The address cannot be repeated. The address is logical and related to the geographical location of the machine. It is not a physical address. It's something logical that can be changed according to the change of the geographical location of the machine. This network layer selects the best path for destination. This is what we call the routing process. Routers, the devices that are called routers, work in this network layer, reads and understands data up to this third layer, layer 3, the network layer. This layer performs fragmentation. If segmentation was not enough to divide the data to be suitable for sending and receiving, we add another process, that is fragmentation, to the data to divide data into smaller chunks. Network layer at the receiver side receives the segments of data from the transport layer, converts segments into packets by adding the addressing information, the sources, the destination, and then finds route for data to be delivered to the receiver. Routes that are designed to any group of data may differ because it is being determined based on the following. It is either the least network overloaded route, or the best route from the point of view of the quality of service, or it is the least route in cost, or according to some delivery priorities, which means that the data has a priority more than other data, so it should take a path that is faster than other data would take. These are the most common criteria for route definition. When we say that the network layer is responsible for identifying logical address, we must give some details about the logical address. It's a unique identifier. It is bound to geographical location of the machine. It is used for end-to-end routing since bound to the geographic location. It can be changed according to the change of the geographical location of the machine. It is not vendor-oriented, as we will see in the next lectures that the physical address is vendor-oriented. The common example for this type of address is the IP address in the TCP/IP protocol suite. Let's sum up both layers, the network and transport layer. The network layer identifies the source machine and the destination machine in any session, while the transport layer guarantees either end-to-end reliable delivery or end-to-end best ever delivery for data across the same machines. These are the main functions of the network and transport layers in the ISO OSI 7 layers. Thank you.